This video is to review variation, and we know that there are three different types of variation: direct, inverse, and joint variation. I've written out the general equations here that we should know. Direct variation, y equals kx, inverse variation, y equals k over x, and joint variation, y equals kxz. The idea with direct variation is that as one thing increases, the other thing increases. Inverse variation, as one thing increases, the other thing decreases. And joint variation, as one thing increases, we have two other things also increasing. So we're going to take a look at one example problem that you have here. And the idea is that it's a really big, long word problem, but it's really not that difficult. You just want to be able to pick out those keywords and write your equation. So the force, is what we're looking at here, is varying directly as the weight. So I'm going to start off with that. So force is varying directly as the weight. The weight of the car, okay, and the square of the speed. So that's also going to be there. And inversely as the radius of the curve. So inversely means I'm going to divide by the radius of the curve. So I'm going to read through this one more time and make sure I have my equation set up correctly. The force needed to keep a car from skidding on a curve varies directly, so I know I need K as a constant, as the weight of the car and the square of the speed, and inversely as the radius of the curve. Okay, so I have my equation. Now it's time to plug in some numbers. Now the idea with variation is that we're going to solve it once. We're going to solve for K, our constant, and then we're going to plug that constant in and solve the actual question that we're trying to get, how much force at the end. So this is kind of a two-part question. So we have a 3,960 pound force, so that number goes here, is equal to, the weight of our car is 2,200, and it's traveling at 30 miles per hour, and we want to keep it from skidding on a curve that's 500 feet. So I have my 3,960. So what I would do here is multiply this times this squared, divide by 500. I'd probably do that all in one step. And if you do that, you will see that you get 3,960. So my K, after all of that, is actually equal to 1. So now I can use that equation. You can plug that K in, or it actually can just go ahead in this particular equation, just drop out. So this is my equation. I can use this to solve any type of question I want to with any numbers. So now this is where it comes down to answering the question. How much force is required to keep a 3,000 pound car traveling at 45 miles an hour from skidding on a curve of a radius of 400 feet? So you multiply 3,000 times 45 squared. Okay, remember, you're only squaring the 45 here, divided by 400. And you should get 15,187.5. And the units here for our force is pounds of force. So that's the answer. If you have more questions about variation, please see your math teacher.